Hey guys, welcome back to Joanne's Learning Hub. Today we'll be learning a fundamental topic in chemistry which you will find as the first section of your IGCSE syllabus. We have been learning this topic since our primary years, but now we'll be diving deeper to get good understanding of the concept which will be important for the coming sections as well. So let's begin. The kinetic particle theory is the idea that everything is made up of tiny particles like atoms, ions, and molecules which are constantly moving around. Now, whether your substance is solid, liquid, or gas depends on how strong the forces of attraction are between the particles of the material. So, now these forces of attraction depends on the material, the temperature, and the pressure of your substance. Now, starting with solids. Solids, they have strong forces of attraction between the particles which holds them very close together in fixed positions. And the key word here is that solids have a very regular lattice arrangement. So, solids, they vibrate on the spot, they have definite shape and definite volume. The hotter the solid becomes, the more they vibrate, and solids can expand slightly when heated. Moving on to liquids. In liquids, there is weaker forces of attraction than in a solid. So they are more randomly arranged and they are free to move in and out of each other and they stick closely together. They have a definite volume but they do not have a definite shape. So they take the shape of the container they are in. The particles are constantly moving with random motion, and if you increase the temperature of the liquid, the faster the particles of liquid will move. That means the kinetic energy of the liquid molecules will increase. And liquids can also expand slightly when they are heated. Now, gases. In gases, the forces of attraction between particles are very weak. So they are free to move and they are very far apart. So their intermolecular spaces is very large. The particles in gases travel in straight lines. Gases do not have a definite shape nor a definite volume and they can fill any container. Gases also move constantly with random motion. If you increase the temperature of the gas, the faster it can move. Now, gases can expand either when they are heated or when their pressure increases. Now, what about compression? Gases, among all the three of solid, liquid, gas, can be compressed the most easily as particles are far apart and they can be squeezed closer together. Now, coming on to changes of state. If you heat or cool a substance, it can change its state. So now when you heat a solid, it will change to liquid, so the process is melting. When you heat a liquid, it will change to gas and the process is boiling or evaporating. Similarly, if you change a gas back to liquid, the process is condensing, and in this process heat is given out. Likewise, when liquid changes to a solid, the process is freezing and again heat is given out. Now, moving on to differences between boiling and evaporation, which is a very common question that's asked. Now, boiling and evaporation both are changes of state that involve liquid changing into a gas. Now, boiling occurs only at the boiling point of the liquid, whereas evaporation occurs at all temperatures below the boiling point of the liquid. Evaporation is a surface phenomenon where more energetic particles that are near the surface of the liquid can escape and become gas particles, whereas boiling occurs throughout the liquid. In boiling, bubbles form throughout the liquid, whereas in evaporation, bubbles do not form throughout the liquid. Now, we can understand that changing the energy of particles will cause a change of state, which is what we had discussed in the previous slide as well. So, suppose we have a solid, maybe an ice cube. When we heat this solid, the particles will gain more kinetic energy. the particles will vibrate more. This will weaken the forces of attraction that is holding the ice cube together, and it will expand. At a certain temperature, which is called the melting point, the particles will have enough energy to break free from their positions, and the solid will turn into a liquid, which in this case the ice cube is melting into water. Now we have the water, liquid. So when the liquid is heated, particles will they'll gain more kinetic energy, they'll move faster, forces of attraction will weaken, and at certain temperature, which is called the boiling point of the liquid, particles will have enough energy to overcome the forces between them and turn into a gas. So the key point here is that the amount of energy needed to cause a substance to change state depends on the strength of forces between the particles. You must also remember that if you cool a substance, the particles will lose energy, the forces between particles will get stronger. So this is what happens when gas changes to liquid and a liquid changes into solid. In the previous slide, we learned that if you heat or cool a substance, it can change state. You can even plot the graphs to show how temperature of a substance will change as you heat or cool the substance. The most important thing you need to remember over here is that when a substance is changing its state, its temperature stays constant. So when you are heating this substance, it is either melting or it is boiling. So this energy which you are supplying to the substance is being used to overcome the forces of attraction between particles. It is not being used to speed up the movement of particles, which is why the temperature remains constant. Similarly, if you are cooling a substance, it is either condensing or freezing. The energy which is being released is coming from formation of new forces of attraction between the particles. It is not being released from the slowing down of the particles. So again, the temperature will stay the same until all of the substance has changed state. So we can see our heating curve as a substance moves from solid to liquid to a gas, and our cooling curve where the substance is moving from gas to liquid to solid. So if we see our heating curve and the cooling curve, the level sections, which means the flat lines, show the change of state. In the heating curve, when the substance moves from solid to liquid, we can see it is melting. When it moves from liquid to gas, it is boiling. In the cooling curve, when the substance is cooling from a gas to liquid, it is condensing, and when it cools from the liquid to a solid, it is freezing. Now let's talk about the effects of temperature and pressure on the volume of a gas. Now, pressure and volume are inversely proportional. So if you increase the pressure, the volume will decrease, and if you decrease the pressure, the volume will increase. Temperature and volume are directly proportional. So if you increase the temperature, the volume will also increase. If you decrease the temperature, volume also will decrease. Now you must be able to explain the effects of this temperature and pressure on the volume of gas in terms of the kinetic particle theory. So now we are decreasing the pressure. So what will happen? Pressure and volume are inversely related, so the volume will increase. How do we explain that? We know that in a gas, the particles have large intermolecular spaces. So the particles in a gas are very far apart. So if you increase the pressure, the particles are being pushed closer together. So the volume of gas will decrease because they are occupying lesser area. If you decrease the pressure, the particles can move further apart, so the volume will increase. So that's the kinetic particle theory explanation of the effect of pressure on volume of gas. Now what about temperature and volume? Now temperature, if you increase the temperature, the volume of gas will also increase. Why? Because if you heat a gas, the particles will gain more kinetic energy, they will move faster, and if they have more energy and they can move faster, they can spread out and occupy more space. So you increase the temperature of gas, it will increase the volume of gas as well. Similarly, if you decrease the temperature, the particles will have lesser kinetic energy, so the volume decreases. Now, diffusion is the movement of molecules and ions from a region of high concentration to a region of low concentration down the concentration gradient as a result of the random movement of particles. Now, you must remember that the rate of diffusion of a gas depends on its molecular mass. So, small, lighter gas molecules can move faster and hence diffuse faster than larger, heavier gas molecules. Now, an experiment to prove this point right is the reaction between gaseous ammonia and hydrochloric acid or the hydrogen chloride gas. This will form solid ammonium chloride. So, there is a glass tube and we take cotton wool soaked in aqueous ammonia and put it in one end of the glass tube, and at the other end we put cotton wool soaked in hydrochloric acid. So both these cotton wool gives off fumes of ammonia gas and hydrogen chloride gas, and they move along the glass tube by diffusion. So you will notice that a ring of white ammonium chloride has formed, but closer to the HCl end of the tube. Why did this happen? Because ammonia has lower relative molecular mass than HCl. So it could diffuse faster than the fumes of hydrochloric acid, which is why the ring formed closer to HCl. So that's the end of today's video. Please do remember to like, share and subscribe to my channel for more videos like this. Thank you.